I may start with making a manual vessel, it's just faster to do. And we will clone that vessel and then program that. I'm going to make something average, not very specialized in a single way. So it's not going to be something with a lot of battery regeneration, because I'm not sure I'm only going to be using energy weapon. I might use something else. So let's take something for hit points. Alright. I will definitely need more wings to have extra weapons. Just 12 modules is not enough for my preferences. If it ends up looking good, it's a coincidence. I'm not trying to create something really fancy here in terms of the visuals. Mostly because we have limited time here. I would rather show you something interesting that is harder for you to do on your own, basically. You can create really interesting vessel designs without my help, right? But for the programming parts, the game doesn't have a good tutorial right now. And the page itself, it doesn't say that much about that part of the game, but it is one of the main parts. So I guess I can fill the gap by showing you how you can do that. I will still try not to create something that is really ugly. If I wouldn't care about the looks of the vessel, I would never create an editor like this. So might as well put some time into that. So it has different, quite decent max speed. The acceleration can be higher. The rotation rate is really good. The only problem is that if you have low acceleration, it will be hard for you to change the direction of the vessel. Imagine you're flying in one direction, then you want to rotate 180 degrees and then fly to other direction. You need to kind of build up the velocity first to negate the current velocity that is moving you forward, and then you build up a new velocity in that other direction. And it's made by applying acceleration per second. So if you have 100 top speed and 100 velocity acceleration, it means you can reach a top speed in 1 second. But if you have this, then it means that it takes more than 2 seconds to reach a top speed. And if you have a current velocity, it will take even more. For instance, it can take 3 or 4 seconds to change the direction. That is a lot, especially in the combat with smaller vessels. That can be punishing for you. So I might consider taking something for acceleration, like this. How about that? The top speed will go down if I add some weapons. It's just we don't have anything else apart from the bodies, wings, and engines. I will definitely use some drone weapons because they're harder to program. But we will not start from that one. This is going to be manually controlled vessel. A good weapon for that is something that can use your skills as a pilot for its benefits. Let's take this weapon and I will show you why. Let me check. Okay, it's saved here. Let me also check that the streaming is working. You can never be too sure, you know? At the very least, I'm going to have my local recording. Doesn't matter. What I want is the game to have a broadcasting label on top of that when you open the Steam shop. I don't think it has one right now. But okay. Or maybe it's not on the web. What if I open the game differently? No, it's not there. You know what? I don't care. Let's just continue with what we've been doing. So the current program is not what we want right now. I'm not going to explain what it does. It was a default program for the weapon. What we're going to do is to control how the weapon is being fired when we press it. When we press a keyboard button to do that. I will add this command here which checks if the key was pressed or not. There is a list of actions you can check. For now the list is very limited and the keys are predefined, but in the future you will be able to assign the exact buttons you want to be a trigger for an action. For instance, it doesn't have to be Z or O for weapon 1, but for now it is. Then we will write that condition value 0 or 1 to a blue flag. This is how we do conditional logic here. If I just add the firing here and toggle the pause, it will fire right away, and then it stops because the weapon is getting overheated. But if I make it blue and restart the simulation before it happened, then you can see that it doesn't fire, but if I press the O button, it does. But it's still very easy to overheat, because I don't know how much heat I have right now. One of the ways to fix that is to display the amount of heat the weapon has right now. Let's do that somewhere on top of our vessel, our position. It will show this value here. If it's less than 100, that means that we can still fire. It's not overheated. But then it reaches 100, it will go over that value, meaning that you have a penalty for overheating. It's still not holding us from making a mistake, but at least we know how to fire the weapon, when we can and when we should avoid that. And if you don't like the positioning of the label, it's rather simple to move that. Let's calculate the position. If I take my position and then use a direction of 90, which is directly down 90 degrees. So 0 degrees is to the right, 90 degrees is to the bottom, to this side of the screen. Let's say it like that. I'm pretty sure it's south. And the distance can be around 80. All we need to do now is to use that location instead of the vessel position, and it will be to the bottom of the vessel, below that. It can be closer, like that, so you can add extra information on your interface if you are designing a manual control vessel, which can be helpful for you. Another thing I can add here is the range of the weapon, because it's hard for you to know how far can you fire the weapon, and there is information like that, the range of the weapon, and from where, from our position, of course. And now I will have a range of my weapon, but since this weapon is so ridiculously good, it has long range. In order to show you the exact radius, I will have to run it in a different arena. This is my vessel, and I will use the same vessel, but using a mercenary there, autopilot. For myself, I'm going to take Android, that will follow the program that I wrote just now. And since I'm the player one, I can see the information like this. So this is the hit level, and this is the range of my weapon. Now that I can scroll the camera, it's much easier. I don't have a control over the movement of the vessel. It's still having its own default program, but at least I can fire, as you see. Now, let's add some controls for the movement. I will demonstrate one feature that the game has that makes it easier to reuse your code. I wrote the program for manual control many times, so it will be weird for me to write it again. I saved it as a steering function. The game will probably have a filter soon enough. But you shouldn't have so many functions, it's just for me right now. Why doesn't it have steering functions here? I wonder. Have I deleted that function at some point? That is quite awkward. But okay, I can live with that. Let's write it from the start. I will need to check for free key presses. All of them will be blue flags. One of them for the forward key, left key, right key. It's forward action, left action, and right action. I just need to switch the mode. Oh, okay, almost there. Like this. Now let's make them conditional so they don't work at the same time, all of them. And now the vessel is not moving, but if I press the buttons, I can control it myself. With that in mind, I can also shoot the enemy. I can kinda see the hit level so I don't overheat, and this allows me to use this weapon more efficiently, as opposed to just firing until it overheats and then nothing will save us, because we can't attack for a few seconds, which is very inefficient. But that's just a half of the problem that we can solve, or that's just a partial solution. What we can do here is not to allow firing if we're about to overheat with that firing shot. This means making additional condition here. Let's take our current overheat level, or just heat level, and if it's higher or equal to 80, we set the blue flag. Just for the example, I'm going to set the teal flag, but it doesn't matter here. And if it's true, then I'm going to exit and stop the execution of the program, not to allow overheating. Now, if I hold the button, it will never overheat. I should probably display the value. I will copy these Control Z my way back. And Control V or paste what I was doing before. You see, this editor is pretty good already, but it's still a demo. It will be even better. So if I hold the button, it will never go over 100, because one shot of this weapon increases the hit level approximately by 15. This could probably be adjusted to be more effective. There is a mechanic over overheating, and it affects the reload speed. As you see, if I fire more, the rate of fire decreases. There is also an energy, so you see my battery is empty right now. I can even display the value right now. Crap. Here's my battery. So if I use my weapon, which takes some battery, it goes down. And if I don't have enough for a shot, it will not shot. This is mostly useful if you want to program something that will retreat if you have low energy, so you have some chances of recovering it and then come back to attack. But for now, I don't need to display the heat or battery level. But I may leave the distance just for convenience. Now I can fight the enemy. They're using the default AI that is written for mercenary pilots. They're not smart, but they can fire quite competently. It depends on the level. This one is level 2. Well, figuratively speaking, because the sandbox mode doesn't have the same levels as in the main game. It just has a weapon mastery of 2, I guess, out of 4. It was programmed using the in-game editor as well. It just has a bunch of programs it's using. Using only one weapon for this amount of health, it can be hard to defeat an enemy because they have a lot of health and our damage is very limited. But it does look that we are winning. But what is missing here? You know that many games that we play today, where you have to fire your shots yourself, they have a prediction points where you probably want to shoot instead of the enemy position that is the enemy itself. We can do that here as well, just to make it easier for us to play using the manual controls. Let me see. It will be only an approximation, though. You can write a better one, but we have an agenda here, right? So I will show you something, but not everything. So let's assume there is a... There is an enemy position, and we want to move it into the velocity direction. And then there is a question for how much. One of the easy ways to approximate that is to take the time to reach of a projectile from our position to the target position using the projectile speed, like this. This is the time in seconds, like 2 seconds. That is not speed or direct distance yet, but we can multiply that by the speed of the target. It could be either the max speed or the current speed. The problem with current speed is that if they change the speed a lot, or they only using half of their speed, which can happen, especially if they're rotating, the speed will change rapidly and the crosshair will move a lot. But still, I will use the current speed. But if you're programming something, you might want to consider that the target, they can move a lot, and they will try to abuse your naive idea of trying to predict where to shoot, where to fire. But it will work for easier enemies anyway. So now that we have a position where it should be when the projectile can reach their position, I can display something in that location. And for the lack of the better thing, I will display the number there. I will probably add something more like display text labels for the debugging tools. And the value is going to be... Let's display the enemy health. The exact value of enemy health, which can be useful. So, now, if I run the game, I will see this position with a number. This is a prediction where I should fire to hit them. The faster they go, the further the number from them. Although the projectile is so fast, this weapon, so it can basically hit them in 1 second. So it's more reliable with other weapons. And also it moves with the enemy, so it's kind of hard to use. But okay. At the very least, we have the number of health the enemy has. Well, it was close, right? At least as close as I can show you right now. So with that in mind, I would say we have a pretty good foundation for manual control, and now we can start making an automated vessel that will oppose us. As we saw before, we can already beat the mercenary level 2 from the perspective of the sandbox. I will try improving the language, increasing the level of them in here. So if I put, for example, mercenary 4, it will be much more harder for me to beat them. But still, that's only one weapon. I should probably add something else to the vessel. I have a feeling that it doesn't work right now, the prediction of the movements. Yeah, it usually shows the further location than it should. Could be the reason that... Could be the problem with the acceleration and the top speed. If you played the Star Control game, or the... It's also known as Orc 1 Masters, I guess it's pronounced like this. You might be familiar with this combat system a little bit. Well, I guess many games have it like that. But what I want to say is that right now I'm controlling the vessel in the very arcadey way, with tank controls, more or less. My energy is low. So in order to improve this vessel, I need to add some weapons that don't rely on energy, or should I say the batteries, and Or there is another way. I can just increase the regeneration rate of the batteries by using a different body type of the vessel. Because right now I have a body that has a lot of health, but it doesn't help to regenerate the battery. But that was the point. We're going to add more weapons that don't rely on the energy that much. The second weapon I'm going to add is missile launcher. Or should I? Okay, let's say it's drones. And for now, in the manual control stuff, how do I want to control them? Okay, let's keep the basic default program for them and make them do their thing for the manual control. Let's see if the damage level is better now. What I want to do is to clone the vessel and change the engines. Only their color. This is to make it easier for me to distinguish between my drones and the enemy drones. If they're going to be red, the drones will also have red engines. Now, should be much more easy for me. Oh, the problem with helping my drones is that this weapon has friendly fire, and I definitely know that I made a few hits. But hey, I'm helping. Get it. Now we have 3-on-1. Doesn't look too good for me. They also don't have energy. Oh, they decided to retreat, no? No. That was a bait. Ah. Now they're doing that. That is a victory, but it's not the perfect one. The only reason I defeated them is that they decided to retreat. This is the logic that mercenaries have. If they feel that they have some chances of losing the battle, they will try to run away just to save their vessel and their lives, I guess. I would call it a... Well, it was a fair battle. I still got less HP than them, even though I got some free hits than they were escaping. So as you can see already, even the generic program, it can pretty competently play against the player. But maybe that's because I'm not the professional player and I never tried to master this vessel. One improvement I can do perhaps is to display the number in a slightly different way. Let me show you what I mean. Aiming at the position that is so far away is hard. What if, instead of that, I would do something different? Also, I don't need this range. We will do something even smarter. So if the vessel the enemy has... Well, I need the distance. The distance is in calculation. Distance between the target position and my position, and it should be not higher than the range of the weapon. And if it's true, then I will display the circle, but in a different way. It will be a crosshair, and it will be displayed in a position where the enemy will be, but in a directional way. So I will calculate the angle from my position and the position we predict, which is B. And then I will move a position of my vessel towards that direction, but only for 80 pixels. And then I will display it in that area, and it should be small, like a crosshair. I will adjust the size, like that. Huh? Is that right? Probably should be closer to me. And smaller. Yeah. Even closer. Good. This is our crosshair. Theoretically, if I fire in this circle, there is a chance that the projectile will hit the enemy. It depends on their movement, of course. But at least it's something. A little bit better than what we had. Now, with that, let me try fighting again. Come here. I have my cheats and hacks now. Oh, I forgot one thing. The problem right now is that it's shown all the time, and I don't know how far can I fire. This is why we were comparing the distance somewhere, right? Here. Because if it's out of range, I don't want it to be shown. Only if it's in range, like this. And another improvement here is that instead of comparing against the target position, I should compare the distance between me and the position we're firing at. Was it B? Sure. Now, should be much better. I'm pretty sure I'm hitting my own drone right now. Haha! How do you like that? I can also switch my target to this one and then the crosshair will help me to fight them. Nice. It's possible to add an action that will read the state of the key, for example tab key, and then switch the target for you. So you don't have to pause the game to do this, and you can do that from the keyboard, from a hotkey. Nicely done. Can you see how much my performance has improved? Just because I can actually hit the enemy. That was a mistake from my part. The problem is that they have the same weapon. If I can fight them, they can fight me from the same distance. I guess my drones are out of ammo. They can't attack enemy anymore, but they can still be my shields. And maybe distract the enemy, if I'm lucky. Ah! No! Don't do that. Oh, I'm feeling so good using this strategy. I will probably not show this to my friend who's going to play the game too, because it makes the game really different from what you usually use. A very few number of players will actually try Android for manual controls, but it opens up so many opportunities. You don't rely on the program of these androids or the levels of the mercenaries. It's mostly your skills of piloting the vessel. It's like a different game. This is what I'm trying to say. Very different game. It somewhat relies on your programming skills, because without the assistance, without extra UI, this is really hard to do. Ah! I would call it this my victory, okay? It feels much better at the very least. And the feeling is important, right? Okay, let's stop improving this vessel and try to program this one. Now, it was already doing some program, and it's not a default program because it was assigned an Android. Oh, mercenary. I wanted to say mercenary, sorry. It's an evening for me, I didn't have enough sleep, I guess. What we want to do now is to assign an Android, so they will use a programming instead of their own program that was created by me before. And if we fight now, the enemy will be much less dangerous. Oh! You know what happened? I cloned the manually controllable vessel, and now I'm controlling both of them. Okay. It should be something different. No manual controlling here. Nothing here. And no drones yet. I will explain everything as it goes later. For now, where do we start? We can start from a simple movement. For now, it doesn't move if I remove everything. That's logical, as expected. The easiest way to move is to just assume the target position and use an autopilot to get there. This is a very dumb way to move, mostly because it makes you very vulnerable from the enemy fire. You're moving in a straight line to the enemy and you get too close. If that's not what you want, then it will play against you. But it's a good start, because it achieved the goal of getting closer to the enemy and attacking them. It also rotates in the direction of the enemy because it's an autopilot. There is a second kind of autopilot that doesn't have auto label near that, but the only difference is that autopilot is going to stop or get slower when you get closer to the target, the waypoint, but this one won't. It will move a little bit differently. As you see, we circle around the target because we can't reach the target. We have velocity that is driving us. That is a little bit better for some vessels because you're avoiding some damage by strafing, basically. The downside is that you may go out of the bounds of the arena when you don't want that. And it's also hard to reach the enemy. You see, we have some time of... how do I call it? Let's call it offline time. The time that you can't fire the enemy. Mostly because you're too far away from them. And maybe that's what you want, but most of the time you don't want that. Unless you have low energy or something. So this is also an easy way to achieve the following mechanic, but it's not very smart or efficient. But that's better than the first one probably, because you will get less damage this way. I need a break of 10 or 20 seconds and we will get back. Okay, I'm back. I'm thinking what can be good for this vessel to make it competent against us. The easiest way to do this is to imagine how would we play with this vessel. And we were moving a lot, and then aligning ourselves against the enemy, firing some shots, and then repositioning ourselves to avoid the firing from the enemy. We can implement that. It's not the simplest one, because the multi-state programs are usually harder to write, at least in this game. They may end up being more efficient because they have different states, but it can get a little bit hard to maintain because the states, they need to have the boundaries that you can cross. For instance, if you're repositioning, but there is an opening that you can fire right now, you shouldn't continue relocating, and you should stop to fire, enter another mode from one state just to make it more efficient. But for simplicity, we will not concern ourselves with this. I will use variable to control the duration in the current state. That is probably one of the simplest ways to do that. I will calculate the current duration of the mode. The duration will be in beta variable. I will subtract the delta time from that. A delta time is the number of seconds, a fractional number, like 0.1, that's passed during the previous run of the program. So imagine this is the number of seconds this current state should be running. And if I subtract the number of time passing from it, and it reaches less than 0 or becomes 0, it means the mode was... the mode is expired. We need to select something else. And now I will compare that against 0. It can become less than 0 if it was 0, for example, or it was less than delta time. So the 0 means that we need to reset our current state. Let's call it 0 in alpha variable. I will also cancel any waypoints we have because it can be a leftover from the previous state. Now we have the logic that will make sure that our states are being cycled. Then if we have depending on the states, we need to do something. Now, if we have a state of 0, then we need to select a new state. I will call this function mod selection. And I will call this function from here. After this, I will exit. There will be a mode called relocation, which makes our vessel choose some point and go there, mostly for navigation. So if the mode is equals to 1, then we're going to call a relocation function. It's quite difficult for me to move something using my touchpad on the laptop, and I can't really connect my external mouse because I only have 2 USB ports. One of them is used for keyboard and the second one is used for the microphone. So either I'm going to be unable to write anything, or you are not going to be able to hear me. The choice is probably obvious. Right, it should be equal. Relocation. The mod selection, for now, it will always choose the mode number 1. And the duration of that mode will be randomized from seconds to 4 seconds, maybe. And that random value will be beta. It better should be better. It better should be better. Okay. So mode selection always chooses the mode 1 with a beta value of a couple of seconds. If we go to relocation, just to debug stuff, Let's print a number of seconds this mode has time left. Should be better, right? It's not working. And I know why, because we're not updating the value here. Now it should be working. This is a timer of a mode. As you can see, when it reaches 0, it becomes higher again, because the mode selection function is working when it's 0, and it reassigns the mode to 1 with a different beta value. But we're not doing anything useful in the relocation function, we're just displaying the value. If we would instead fly forward, then you will see the movement here. But that's not what we are after. The relocation will work like this. Let's see. The relocation is being executed when the program is not sure that it has a good targeting range, and when we are about to change our location to avoid return fire. That means that it can be pretty random, it doesn't matter where we end up. Well, it does matter, but not that much. So let's take a center position of the map and then add a lot of random to that. So it can basically be almost anywhere from within the map. Take the angle from our position to that point, and to limit the amount of distance we're going to fly there, I will use move position. The distance should be randomized, so it's less predictable. Then it will be constantly moving randomly, switching the waypoints all the time, every frame. I will just show it to you, but it's not what we want. I will add this. You see the line, it always differently located, because every frame we're choosing a random point, so the vessel doesn't know where to go. What we can do to fix that, well, one of the options is to see if the current waypoint is not 0. Then we're not doing anything, just exiting. Now, if the point is selected, the vessel will fly there for at least a couple of seconds. This number of seconds depend on the beta value, because we're clearing the waypoints every beta seconds, and we choose a new one when the relocation function starts. If it happens to reach the waypoint before the mode is changed, a new waypoint will be selected, so it will work nonetheless. As you can see right now, it kinda moves a little bit randomly, and that's good. That's all we needed from that to reposition itself. There are better ways to reposition, to adjust your waypoint based on the enemy position and whether they're likely to intercept you in this direction or not. But for now, that's good enough. Also note that we're not going to go out of bounds, most likely, because we're choosing a waypoint location within the map, using the center of the arena as a baseline for the middle point of our randomization. Now that we have random movement, let's add something else. If the vessel is moving randomly, it's not good enough, but I will stop here for the movements for now and program the weapon. As before, it can't fire, and if I add a fire command, it will just overheat. We already established that we need to check for the heat level for this weapon to work properly. And this is what I'm going to do here as well. I will also encode it in this very same way. No firing if the weapon is about to overheat, and then we need to know when to fire. If I add this instruction here, it will fire constantly. The chances of hitting the enemy are not very high, only if it happens to be in front of us. This is wasting our energy and also makes the rate of fire slower than it should be, because it's about to be overheated. The easy way to fix that, well, there are different ways to do that. I'm not even going to do any predictions here. I will check the rectangle and against the position of the target. To do that, I need to get second point of reference. So I take my position, move it into the direction of my vessel facing, or maybe the part facing is more reliable, because if you rotate the part, it will reflect that here. The distance should be the range of the weapon. Now I have a second point. Where was it? Okay. So that line of the width of 3 from A to B, where A is our position and the B is the position I just used here, or evaluated this expression into, and we're checking for the target position. If it's there, then we're going to fire. Now it will not fire unless there is an enemy in front of us. Again, we're flying randomly, so it's not very likely for us to find the target. But if it happens to be in front of us, we're going to attack that target. We just need to add some behavior for the movement, that it actually tries to rotate into direction of the enemy or get closer to enemy. But that's the next step. For now, I will just show you that if we're in front of that target, it will attack us. Stop! Help me help you! It's dodging so fast. No, I don't want to attack you! Yeah, it was trying to shoot. You see? Once. It fired once. I guess that already proves our point, but I want more. Okay, the second one. That's good enough. It kinda tries. Maybe 3 is not enough. Let's say to 5, I guess. That's alright. And then let's modify the movement. Now let's change the mod selection function. When we're going to set the relocation, well, the easiest way is to do it randomly. So if the chance 30% is triggered, then we'll do this stuff and exit. Or should we return? Let's just return. I guess when we return, we continue by... Oh no, the mod selection does exit, so it doesn't matter. Could be exit, could be return, doesn't really affect anything. That's the evasion tactic. What's about the firing? And we need to follow the target to find them, and also to rotate in a way that our weapon can fire at them. Let's assume we only have 2 modes for now, and if the mode is not set to the relocation, then it's going to be set to the rotation mode. The rotation mode should be shorter, because it's only working if we have some velocity. If we are standing, we're going to be an easy target for the enemy while we are standing there. But still, 30% is not enough to overcome this, but we will add more mode later, most likely. So if the mode is... if the mode is 2... Facing target. This one is pretty simple. I could use left and right in combination with the angle calculation, but it's easier for me to use this helper function. Target facing will rotate the vessel into the position of the enemy. So you see, now it's relocating, now it's rotating. Relocating, rotating, relocating, rotating. It tries to rotate using the shortest angle towards the target, and if everything goes right, it fires. What it doesn't take into consideration is that the target is moving. Let's also code the drone launcher a little bit. The drone ID is going to be 0 for the operator. The operator is the vessel itself. So the program starts for every unit controlled by the program in this drone launcher. Put it simply, it will be executed 3 times. Once for the operator, and they will have ID of 0. Then for the first drone, they will have ID of 1, and then for the second drone, which will have ID of 2. The drones ignore the launch command, because it's only for operator, and then the operator gets here, they return for the program, and leaving this entire program for the droids. If I unpause now, the vessel will spawn 2 drones that will do nothing. They will probably just fly forward like this. They still can fire because you're not programming the firing of the drones, you only control their movements. Let's make it more interesting. Now the drones will have their position near the spaceship. The only thing I need to do is to add the position of the vessel to that, the facing angle. So I made a little mistake in there. Now, one of them is to the left side and another one is to the right side. At least you can see their waypoints. It's hard for them to catch up because the vessel is not waiting for them and they only have one engine. It can work with the slower vessels. This one is quite fast. And they have these positions assigned to them based on their ID. So one drone will always be on the left side and the second is on the right side. Well, left and right side, that's what matters. If I happen to say it incorrectly. They kinda try to follow this information, but they can get desynchronized if one of them gets slowed down, etc. What I will do is that I will ask them to choose a target every time that is the closest to them, preferring the drones, so they will attack the enemy drones first, if there is a possibility of doing that. Perhaps they should be circling around the target from both sides. That could be more interesting. So now they have, let it be this. Now they're following the target from two sides. It could be a drone or a vessel. That should be good enough for this battle. One thing that they miss is that they don't know that there is a friendly fire. And the enemy vessel is ending up hurting their own drones. I'm going to fix that during the next iteration. But again, I'm doing this myself as well. As you see the drones, they're attacking other drones because they have this priority in their program. Wait, are they actually doing that? Is it Android? It is. I just wasn't sure. As you see, the enemy is trying to switch from one mode to another, from firing when rotating to relocating. That means that we can't backfire at them without taking damage, because they will change their location and we will miss, and then they will catch us. because they will enter the second mode. But we can use this to our advantage. For example, now I know that they're attacking, but soon they will switch to moving position, to move position to relocation, and I can attack them freely. Now I should be running. Ah. Let's call it pretty decent for now. And the improvement that we can do is to stop firing if there is anyone in front of us who we don't want to hurt, like drones, for example. I will show you an example when it attacks the drones. Well, we should make it visual then. I will use a function called scan object count, and we will scan for friends instead of enemies. The direction is the part direction, and the distance is something around its range. Since it's a number, it can be 0, 1 or 2 in this case. I will use it as a conditional number, so if it's not 0, I will exit. Not only that, just for you to see that it works, I will use a color function here. Ah, crap. Okay, I need to make it like that. So, otherwise it should be 0. So when the red button is highlighted, then there is a friendly unit in front of us. There. Now it's flashing, and it knows that there is an enemy there. And it stopped firing, but unfortunately one projectile was already launched, and it can't be helped. But otherwise, well, okay, it's not perfect, let's say it like that. But now, as you see, it can detect that there is a friendly unit in front of it. I will probably increase the range, the arc. I can even keep the colors, doesn't matter. Now it should be more careful. my... Okay, my drones are suddenly all disappeared. So are your drones. We wanted to check the friendly fire, so we done what we wanted in this match, at least. That's almost everything I wanted to show during this stream. It's only intended to be an introductory level, just to showcase what you can do with manual controls and the auto controls. But let's do something else, a little bit different, right? Assume that we have the same program as here, but a little bit different. I will show you. I will import this function, or export that, but first I need to name and clone it. Now I can import that function from here. And call it from the main. I could also copy here, but it's not a problem. I can call it. Now, instead of the target position, they will always use the operator position. They will be close to me, like that. Here are two drones. They are positioned on the sides of my vessel. That's what we've seen before. That's not new. But the new stuff is going to be here. They will use the variable here, the global variable. Let's use gamma for this. I could use alpha or beta, they're not shared with the blue ones, the local variables, but it will be gamma. It is beautiful. Now that's enough change for now, and or I should probably do it a little bit differently. Let me do it right now. It should be a calculation of gamma plus something, so we can set the default value. So gamma plus 90 or 80, and use that instead. So it's 80 by default, but if gamma is not 0, then it will affect things. How do I do that? How do I affect the gamma? Easy. If I press the button, the second weapon button, for instance, from here, or okay, let's press it like that. The second weapon. If I do that, then shoot, I'm missing the button here that I want to use. Alright, it will only work in one direction. I should really add the weapon free button or something else. But doesn't matter for now. The phrase that I used more than 10 times today, or even more. When I press that button, it will cause the gamma to increase by 20, and I will change it to the click instead of the press. Now, every time I press weapon 2, the distance between me and drones will increase. I'm pressing the button and nothing happens. That is because I'm not saving it properly. Let me change this and this. Done. Now, you see, I'm pressing the button and they flying away. If there was a second button, they would be going back to me. So in a way, I can control them even manually by assigning the buttons that are performed in the navigation bridge, the one that handles the movement. It can assign the variables that are read in the drone launcher program. As a hack for now, I can do it like that if the gamma happened to be more than 300, then fall back to 0. Now, theoretically, if I increase the radius too much, they should go back closer to me. Yeah, it happened. That's just a demonstration of how I can do that. Another interesting stuff you can do is using the time. Let's assume that we want them to rotate around us for some reason. We can add the time value to the angle we computed and use that instead. Now they have a rotating... Wait. No, it's different. Different variable. Okay, it's I. Okay, it should be G, and then it's J. But it rotates too fast, right? The drones can't fly that fast. Oh, because that's a multiplication of the addition. Now it should be okay. The reason it's so slow is that they're rotating 1 degree per second. We can increase this number by multiplying the time by some factor. Let's say a factor of 10 or 15. And then we use that evaluation instead of the time. Now their waypoints are rotating in a faster way, and they can actually rotate around the vessel. If I make it even higher, for example 30, they will rotate even faster. There should be a sweet spot to get with these drones because they have a limit of their speed, but this one looks good. Again, if I press P button, they will fly further. I hope you like this video because it can be hard to figure out how to program in this game by your own. I hope this video helps you, at least gives you some idea what you can do and how to make manual controls, for instance. There should probably be more of the videos like this, maybe even more structural ones, more structured ones instead of just a random stream. But for now, it's better than nothing. In any case, I'm glad that you joined me today. And maybe it will be useful even after the stream, because I will leave the recording on the YouTube. But for now, bye!